Awesome, thank you, sir. So I try this, and it shouldn't, hopefully it won't take long to realize, oh, there's no sign in there. This isn't gonna work. Because when you solve for dx in terms of du, this will never cancel, right? This isn't gonna cancel. Is there anything else I just thought of this. Let me show you a little trick. So this is one, you don't have to do this, but if you know trig identities really well, you might realize that equals what? Yeah. 1.
It was uncertain.
But it's 1. Yeah, so that's like the ruler of all trig identities. This is just a really good thing to know. You won't need it for the exam, not at all. But notice that also means that I could come over here and I'm going to pull away a cosine squared and I'm going to this. I could rewrite this in terms of sine because I could use this. And then what if I do this? Then this. And now substitution might not be that bad. What if I let u equal sine of x? Oh my goodness. And this. And this is just du. And it's just the power rule. So check that, that is quite beautiful, right? So this is going to be u minus 1/3 u cubed plus c, and then I back substitute, and I've got sine of x minus 1/3 sine cubed of x plus c, and that's cool. So we could do that. Now I don't expect you to know these trig tricks. This isn't going to be something that you have to know. If you can see this and do it, like rock it, like truly enjoy those trig skills that you have. But I'm not required. I gave up long ago required trig skills. It just became too painful for everyone because folks just don't get taught trig. It's not your fault. It's just like the people who gave you your mathematical background didn't give you a strong trig background, and that's not your fault. They had you do a lot of shit on calculators and stuff, probably, right? It's like not helpful. So, okay, so maybe you know that trick, maybe you don't. You don't know that trick. Substitution isn't going to work. That doesn't look like a partial fractions thing because there's no fraction. So, definitely not doing partial fractions as in the lecture from Friday. So, oh shit, okay, so what's my other options? Let's rewrite this. What else can I do?
We'll get a table.
Table. If all else fails, see if you got a table. And you have the mother of all tables that I gave you, that Stewart table. So let's try table. If you have that table with you, check it out. If you don't have it and you have your laptop, which everybody hopefully has some kind of digital, yeah, everybody's got a laptop. Look up, just Google Stewart integral table. So, and you'll find it. It's under Purdue. That's what started that whole too much information story. So I go to that table, and let's go through that table together, because looking for the things that might match is part of the skills, and you will have to do this on the exam, absolutely. I will give you a portion of this table. I don't expect you to print out the whole 12-page thing or whatever it is. So starting on page 6, there are formulas. Take a moment, do yourself a favor. I just have to blow that up, put that into old man mode. Blind guy mode. I see? Do I see anything that can help? I'm gonna give you a formula number. 74.
I
74.
thought 68.
It's, yeah, 68.
So both, you are both correct, absolutely. So 68, check out formula 68 on page 9. It gives us this exact integral, right? And let's write out what they have there. Cassie, would you mind reading it to me? So this is 68.
1/3 times 2 plus cosine squared u times sine u plus c.
It says like this?
Yes, with u's instead of the x's.
Yeah, but that sounds weird. That 2/3. Oh, I think that's okay. I think I know what's up there. Yeah, okay. It's disturbing. Doesn't quite look like this at all, does it? That's because it's a trig identity away from the truth. So I could take this thing here. Notice how that one's all in terms of sines? Let me just show you this. Cosine squared from that last identity is 1 minus sine squared. So what if I took this, and don't write this down if you don't need to do this. Just kind of follow, that's what I prefer you do. I'm gonna replace this with, look at that, so that becomes a 3. I'm feeling pretty damn good about this shit. So this is 1 sine minus 1/3 sine cubed. So this same answer just looks different because of trig identities. So we're good, we're golden. So that's one way to do this. Let's check out, what was the formula you said, Olivia? 74. Yes, ma'am, indeed. So check out 74, because that's kind of where I want to be talking today. And I'm going to expect you to do something like this. In fact, that web work 3 requires you to do something like this. I'm pretty sure. I hope I gave you that. So let's look at formula 74 says this. It's what's called a recursive formula. And it says integral of cosine to the nth u du is equal to 1 over n, so it diminishes the power, so 1 over n cos n minus 1 u plus, and then it gives us another integral, n minus 1 over n, bless you, integral cosine n minus 2, okay, cosine to the power n minus 2x dx. So this is a recursive formula. It actually relies on another integral, and notice that what happens is the power of the cosine diminishes by 2 when we move from this integral to this integral. So it's a way to knock that power down 2 at a time. So let's use that formula here. What's n for us? 3. 3, absolutely. Because we have cosine cubed. So for us, n equals 3, and I have to identify that. And so by this formula, then it's 1/3 cos, what's going to be the exponent of this cos? 2. It's 1, yep, it's n minus 1, it's 1 less, and let's use x's for our problem because we were an x. And then plus, what's the coefficient, or what's the coefficient out front?
2/3.
2/3 solid. N minus 1 is 2, n is 3. Integral cosine, what power? 1. Cosine the first, x dx. I can do that in my head. That's just a good old cosine. Cosine of the first. So, then I whack this through, 1/3 cosine squared of x plus, and then that came from sine, right? So 2/3 sine of x plus c. Doesn't look like any of the answers we've had so far, I think, right? Oh wait, is it that? Not quite. Wait a minute. Yeah, okay. Why do I not have a cube? does
It's
it?
right before the n minus 1 over m.
Oh, it's like here? Like that?
Yeah, it's like
Times
plus.
this integral?
The times is with the cosine, and that's
Oh.
plus the.
Oh, okay. Oh gosh, thank you.
You're
Yes.
That's why I was very confused for a second.
Yeah, no shit, that would totally do it. So it's actually here, and so it's times sine of u like
Mhm.
that. Sorry, cool. God, 'cause otherwise, so this would be sine of x plus that. Put a parenthesis there, so this doesn't look too bad. And then this, let me fix it up. Like so. And that actually is that top answer. That's this guy right here. If you check it out, those are the same. Just do the distributing, you get 2/3 sine of x plus 1/3 cos squared sine. That's right here. So this formula knocked it out for us. Let's practice. Let me give you one to do. What about, don't be upset. That's the best way to make people upset. To tell them, what I'm about to tell you might be upsetting. How would I do this? Bless you. Let's take a minute, and you might need to come back. You might want this answer. So see if you can use that formula to the recursive formula. This one right here. Let me write it out a little better because I did F it up. What's n, by the way? 5. Cool. Let's just make sure we're all on the right page. Yes, ma'am.
So, I'm good.
Oh.
Like, so in the instances where it goes back to the integral, do you want us to solve for the integral that it's asking for in the answer and just keep going?
Keep unraveling it.
Cool.
Pull the telescope up. Yeah, exactly. It is cool. You need fun. How do we feel in that first iteration? Yeah, so you want to write that out? Do I need to do any work here? I do, but have I done that work?
No.
Yeah, right? We actually just cranked that one out. So, had we not done this, we would have had to use this formula again to now do this one here. So I would have to apply the formula with n equals 3 to get that one worked out. But we've done that. We've done the self-referencing all the way down the chain. So we are pretty much done, sans just simplifying. I'm just gonna copy that thing down. And then, you know, while you're writing this, think about how grateful you are for tables. You know, like say a little prayer for the table, that prayer of gratitude. Because this is not obvious in anyone's mind. Maybe like Euler or Leoville. Let's see there. It's E15. And that's my final answer. There's one like this on the webwork, at least one. But that's how you do it. You want to recurse that formula, use the self-referencing to work your way down to something you can do. Let's practice one more, because you got that table.
Dr. T.
Yes.
Can we also use Formula 68,
Oh, let's take a look.
like for the second pack?
Absolutely, Josh. Yeah. Yeah, so when you got to here, you could go, oh, I've got a formula just for that, and perfect. Absolutely. Perfect. Yeah, actually, let's go formula hunting. Let's go on a safari. Let's try that one. We need to hunt for a formula. And then I'll show you another way to do it. What formula are we looking at? What formula are you looking at? Anybody got one yet? Have we cited it?
93.
Ooh, 93. Whoa, 93 would work. Yeah. There's one before that, kind of like in that way Josh was pointing out, the like there's a slightly simpler one, Lou, but 93 is solid. Nothing wrong with that. But you're in the right section.
Is it 87?
It is 87. So you might be like, whoa, it doesn't have u squared in the formula. That's because u can be anything. So we have to catch a rhythm here. Check it out. If so you think to yourself, okay, could it be this? You lay this template over and you say, well, that if it is, then u would have to be this. And then du would have to be this, and oh my goodness, I'm just a 2 away from that. So this requires a formula and substitution. So what we're gonna do here for this one, so this is good. We're gonna let u equal x squared in our original integral, and then du is 2x dx. And that means that dx, so I do the substitution right now. Dx is du over 2x. And then I do the sub, and so I've got integral inverse sine of u, x, du over 2x. That gives me a nice 1/2 out in front. And then it's formula time. So now it's just that formula with a little 1/2 times it in the front. So we can go to that formula, which is very interesting looking. And it says that's u inverse sine of u, so u arc sine of u, plus, I think, maybe it's a minus, wait, was it a plus or minus? Yeah, plus. plus root 1 minus u squared plus c. And there's a 1/2 times that whole formula that I put in front because I needed to do that change, that differential change. And so I got that factor. And so now I can just back substitute and I'm done. It's 1/2 u is equal to x squared, inverse sine of x squared plus square root 1 minus x squared squared, x to the 4th. And there's 1/2 of them. Forgot to distribute. C can take anything. It just make it C again. Half C is the same thing as C. It's all good. It's like one of the simple joys in our life. C takes all our troubles, washes them away. It eats everything. That's the answer for that one. And yeah, I think I'm going to stop there with that. I'm not going to show you the other thing. I was going to show you how to derive this formula, but
It's Monday.
okay, fair enough. Fair enough. Any questions on this, friends? This is slightly like we're on a boat, a little seasickness possibly. I'm not sure. Let me give you one now. You decide how to do this problem. This is for you. I'm not saying it's a table. I'm not saying it's not a table. Might be both those answers might be right. It might be table and not a table. Might be a different kind of table, like a tabular thing or something like that. Your turn. Knock it out of the park. See which one you used? I didn't know it was. 82. So that one is not gonna work. Let's talk about why. I'm glad we had this conversation. So first off, you would need to do like a u substitution anyway, right? So like because u would have to be 2x. So let's talk about that. But then notice here how it's got the variable sine of u, but then this is just u to the 1st power. And up there we've got x to the 4th. So Vivian, if u is going to be 2x, that's like u to the 4th out in front, right? So there might be just, yeah, there you go. And you let u be 2x. Yeah, does that make sense? Okay. But then I think there's an easier way. Tabular integration. So, yeah, that's my name. There is a formula. I feel like that formula could be painful to use. Remember those special formulas that I absolutely have on my note sheet for the exam. You will get a single page, double-sided notes. These should be on there. Those are quick. Oh, you already got it? Okay, okay, okay. No pressure, just thought. Okay, nice. Yeah, looks good. Got it, yeah.
It's really long.
It'd be worse if you had to do integration by parts 4 times, though.
Ooh.
Way worse. Ooh, easy, buddy. Easy partner. That's what your table should look like, I think. Let me know if I screwed anything up. It can happen with all those sign changes. Does anybody want me to talk about what I did there? Just like a slight head, like an auction. It's like a wink. You're good. I mean, you know I'm gonna talk about it anyway, but. All right, cool. Everybody's cranking. I like it. Different colors. Certainly called for. So, remember the setup. The thing that becomes easier with differentiation goes in this differentiate column, becomes simpler. Usually here, there's gonna be a piece that oscillates. It's gonna be an E to something, or a sine, or a cosine. That's what this process essentially is best for. And then you're gonna prime this, so you always start plus, minus, plus, minus, plus, minus, and you always use this grouping scheme. So that's the trick you gotta remember, that it's like a little bit of a shift. And that's where you multiply. You don't need to do the 0, because that'll just be 0. So then, multiply along those and add the results, and you are done. Just gotta be careful. And don't forget to incorporate the sign here and the sign there, because that often is going to be very important, and they're gonna change a lot, especially with the trig function. So my first term is plus x to the 4th times negative 1/2 cos 2x. So that's negative 1/2 x to the 4th cos 2x. And then I've got minus 4x cubed times negative 1/4 sine of 2x. And so that's plus positive 1 x cubed, which is quite amazing and shocking, sine of 2x. And then the next one's gonna be plus 3 halves? Yeah, 3 halves, so plus halves x squared cos 2x. I'm just simplifying 12/8, you know, because it's just kind of the way I roll. 24/16 is 3 halves. What? I can't believe it. And then the last one, finally, 24/32. If that is 3 halves, no, it's not gonna be. What is that, 2/3? No. It's 24/32 simplified to 3/3. So then minus 3/4 cos 2x plus c. Like, all you really need to know is the process, right? That specific answer, I wouldn't don't memorize that or anything. Never use it again. Anything you'd like to talk about here? Okay. I am going to let you take the rest of the time to work on that web work. I would like you to do that. Notice I have not addressed partial fractions because I want everybody to watch that freaking lecture first, because otherwise it's just not going to be worth it. So let's just start knocking out that web work. So first 4 problems are parts. Second 4 problems are partial fractions. Next 4 are table. Last bits are wild. We'll extend that web work a bit so that just to minimize your stress, we'll extend it to Thursday night. I would try to get it done as soon as possible.
Are we gonna need anything in the table for the test, or?
Oh, that's a good question. Yeah, like that sign quiz graph, the graph thing that we never did, that I knew we wouldn't do, that I said we'd do, and then we fucking never did it, like everybody knew would happen. But that was COVID. We would have done it. So let's see, Kitra. I would put, yeah, and I'll give you some tips in the review guide, but I mean like examples of parts, the formula for parts, maybe just some examples of each kind of problem, the partial fractions, like tips to yourself on how to do that with a little example. Right now, that's all I can think of. But I will detail that more in the review guide.
I would also like assistance if.
I think, is that a like thumbs up, come on by, I need help? Or is that like thumbs up, this rocking? Cool, because either way, that's good.
I did most of them. 5 and 7, I had a little calculator here to try to walk through the steps, but I'm just not getting it.
Okay, let's take a look.
I also put 3
So,
problems on the same page.
First step is, so this can't be done yet. Partial fractions can only be done when the degree of the numerator is less than the degree of the denominator.
Cool.
So you have to do long division first. So you did that. Oh, like this one.
Okay,
This one
I
would
can
work.
long
So you have to do long,
fun.
isn't it? I know. I think you're making. Yeah, I agree. It's freaking awesome. So you have to do long division on that first.
Okay.
And then the result, you'll have a little fraction at the end with this denominator. Then you can par frac that thing.
That's nice.
Yeah.
Actually, okay.
Cool.
So
Yes.
with this one though, I tried to break up the denominator. And
So no.
got
So this is
mixed up in
one.
my
This
brain.
is a repeated factor. I do that at the end. You watch them.
It's good. I went through and I was like,
I would watch the end of it because this is a repeated factor. Let me at least give you. I'll do this if you promise me you'll go watch the example.
I just was busy this weekend. I
Okay.
went to a retreat with Dave and then came back home and then immediately had an OAP trip and then worked until 11 o'clock last night. So
Okay, it's okay. It's okay.
I've been doing a lot.
All right. I'm going to need documentation before I answer this question. All right. Now, so when you think about how you could add fractions to get something like this, we've got x squared over x minus 1 cubed. So all the fractions probably need to involve x minus 1. But think about how it would work. You would need, certainly this is a possibility, x minus 1 cubed with some constant on top. But I could also have an x minus 1 squared with a different constant on front. And then I could have just plain old x minus 1. And I have to allow for the greatest generality here. So now, any one of these, if I just had the integral of any one of these, it's like a u substitution and a power rule. Like this is natural log, that's just power rule, n equals -2, n equals -3, power rule. So if I can get it broken down like this, like it's awesome. So you just have to think, how, if you added these fractions together, what would you need? You would need a common denominator. And the common denominator would be x minus 1 quantity cubed. Do you see that?
And so you would need to do it times x minus 1 plus x minus 1.
Yes, but then the next step, so this is like the setup. This is the stage I call the setup. And then there's the flattening stage, which you are doing here. Yeah, so then you flatten this. So multiply through this. X squared equals A.
I'll also give you a fresh page so you're not missing.
Oh, it's okay, it's okay. But you can clean this up and fix it up. Now, you can get you by picking specific x values.
So that's this one there, this is the one.
So yeah, so this I would just erase all that. But so
Yeah.
so here, so now this has to be true for all x. So pick specific x values. There's some really nice ones. You're going to get 3 equations in A, B, and C by using different x values. Use those 3 equations to find A, B, and C.
So,
Yeah, go.
never mind, wait. How did you decide that these were the powers they needed to be 2? Is it just how it is
With a repeated factor like that,
you
yeah.
just do down by each exponent
Yeah,
at a time?
because you're looking for the most general sum of fractions that could be that fraction.
Okay.
And this is the most general possible way, because somehow we gotta get this weird x squared on top when we add these things together. We need to figure out the A, B, and C values that are going to, when I multiply this one by x minus 1 squared, this one by x minus 1, and then just get them all together. I need the A, B, and C values that are gonna make that all simplified to just a single x squared.
Cool.
But yeah, we have to think of the most general possible decomposition.
Okie dokie.
Yeah? Give it a shot.
And just with the
Yes.
web work, it doesn't like how I reduce sometimes, and so it's like reduce more or reduce less, and I
Show
just have
me.
to like go back a step. Well, I fixed it so it doesn't exist anymore.
Oh, sure.
But like, how do I know when to stop reducing?
I need to see what we're talking about,
Like,
because I don't quite understand.
Sometimes I'll leave like 1/2 times this whole term, and it wants me to put it like over or like move the fraction inside. It's just really weird.
Next time it happens,
Just that.
just please ask me and have me look at it, and then I'll see.
Coolio.
Does that sound good? Because potentially, there could be something weird with parentheses that maybe just makes it, you know.
So.
Yeah, and sometimes if you use a lot, sometimes things can get way too crazy with that.
Exactly.
So just, I have to see an
Okay.
example, but next time, just stop right away and let me know, and I'll look at it.
Coolio. Thank you very much.
You're welcome. Hey, Vivi, yes. Okay. Cool, that looks great, great setup. Good job. Yep, perfect. I love it. Watch the video. It's so obvious, but yeah, beautiful. So you got 0 equals 9, and then minus 3 plus. What's what? See, what's the problem? That's your problem. There you go. But you're rocking it. So good. Yeah. I would go, yeah, it's kind of tough, right? So you got 0 and 3, those are good, but you know what, there's nothing wrong with 1. Yeah, I would go with 1 just because it's easier to work with. What about 4? Do you see why? because 4 minus 3 is 1. So when you plug in 4, that'll just become B plus C. Yeah, there you go, awesome, good job, really good job.
I noticed that if I did this on the table, it would just keep multiplying and multiplying.
Oh, so I see what's wrong here. So, excuse me, so you lost your E.
No,
Oh, okay, you didn't, you
and
didn't.
that's the problem.
That
It
is,
just keeps
yes,
going.
yes, it does keep going, so that one will never hit 0. So this one, yeah, so this is one of those special ones where, this is a table, actually. Oh, yeah, I think I lied, Question number 1 on the web work is probably best done with a table. Are you leaving? Okay, cool. So question 1 is like this. Was that a cos, Lou?
Sine.
Sine. You'll either have this or this. This is one of those ones where it repeated. We did parts multiple times till it repeated, then solved for the thing. I would just go to the table. There's a formula for this in there, so Lou, that's my suggestion there.
Right.
So I lied. Ladies, are you good? Do you have a question? I feel like there's a question brewing. Am I wrong?
Not yet.
Okay,
Not
awesome,
yet. My
awesome.
computer's not back.
Oh, that's okay, yeah, okay, great. What's up, Josh?
So whenever you're working these out, you had mentioned table 87,
Yes, sir.
and you got to do the X. So this X in here, right? Where did it go?
Canceled with 2x from the dx. So we let u equal x squared. So du was 2x dx. And then I solved for the dx, which was du over 2x. I replaced that dx with du over 2x. And then the point was these, for those to cancel out.
Okay, so then it'll just be du over X.
Yes, sir. No, it'll just be du over 2.
Oh, du over 2, and that's the one out. Okay, okay.
Yeah.
Okay,
Make sense?
Yeah, that
Awesome.
does.
Great. You're okay. Yep. That's all good. I knew it was kind of just like there's like clouds building. Yes.
Would it be this one? Would you use this one to solve for this one?
No.
No?
Because that's U to the end, not E to the. Yeah, let's look
Okay.
together. Let's keep going down. Here, see here.
Oh.
Yeah, you good?
Yeah.
Yeah, that's it.
Okay.
That's it.
Okay.
You're welcome. Cassie, you good? Okay. Ladies, is it good here? Yeah. Okay, awesome. All right. Okay, so where can I write? Oh, it's from here, actually. You got it down. So, so that K here is the number in front of the 2. So, for example, so then integral of sine 2x dx. So here it's the K equals 2. So lay that over here. Does that make sense? What I'm saying? So then that's negative 1/2 cos 2x plus c. So then I had to integrate this thing here, and every time I do it, another half is going to come out in front. So every time I integrate, ignore the number in the front, just think every time you integrate one of these up, another 1/2 comes out in front, and then the sign's going to change depending on if I'm doing a cosine or a sine. Does that make sense? And so it's just kind of an accumulated half times half times half times half. Yeah? Okay, great. You're welcome.
Yeah, I know that, yeah, that's what I want to talk about, yeah, okay, well, good to see you here today, I'm very happy.
All good, you're all good. I'm gonna run to the restroom, friends, I'll be right back. I've seen this, I've seen.
Says I'm wrong. Says I'm
Well,
wrong.
let's take a look. Why close this? Please go.
Do I need to simplify things?
Alright, let's take a look. Let's see if this is one of those things that Kendra's talking about. Alright, let's see. Okay, let's see, can you pull the formula for me real quick, please?
Yes.
Thank you. Oh, I see the problem. I totally see.
Problem.
So, okay, let's check it out. So once we get the A from the E and the B from the sign, we do this. There's no variable out in front. So there's just an A here, a B, and then a B and a B. So let's look at let's go back to your answer. So see here how there's an X in your answer, but there's no variable in front of that one. In fact, that should be a 5.
Oh,
Change that, do you see what I'm saying?
Yeah.
Change that X to a 5. Let's try. Okay, not quite. Okay, so let's see. Can I see the formula? I'm sorry, one more time. Or just
Oh,
write
yeah,
it down.
write it
Thank
down.
you, thank you. So, okay, so let's go through, maybe I didn't see, I thought I saw, I didn't think you had mine set. Let's see, so we've got E to the 7, so okay, 7 here is 5, right? Yeah, so, okay, so it's 7. Oh, look at your formula here. So this is sine first, then cos, so just change those two and that should do it.
There you go.
Beautiful. You were close. You were
Yeah.
hella close.
Okay.
You're right there, Josh. Partial fraction.
Also for this one,
Yeah.
noticed that it would be impossible to do.
Maybe something here, just go over here. Where's
Yeah.
it?
Yeah, I was 111, and it's like if they're all plus one, there's no way to get it out.
No, it's okay. So let's start, here, let me show you. So this setup, it is gonna be plus 1
Plus one
cubed, plus 1 squared.
squared.
You have all the
plus
powers.
one.
Yeah, then plus 1 at
Yeah,
first.
okay, that makes
And
sense.
then when you multiply through by this, that'll go away. This will be to the first, and then it'll be squared. Those are all plus 1s in there.
Okay.
Does that make sense?
Yeah.
Okay,
Okay.
yeah.
Thank you.
You're welcome.
Oh, you're fine, David. Problem 2, is it parts as well?
Yes,
It is? So
it is, or it's a table if you want.
I was gonna use this one, 92.
Yeah. Not 92 though, because, so let's look at it. Notice how there's a variable out in front. There's a simpler version of this formula that's just pure arctan. But I'll show you I'm gonna show you how to do it with parts too. So, it's probably down. It's probably
Down.
and there might even be like a U to the end, arc 10, but there should just be a plain old arc 10. Can I look real quick? Thank you. So let's see, because I just can't see that well. There you go. Thanks. Yeah. Get my spectacles out. Okay. All right. Let's take a look here. So.
You can go full screen. if you
Oh,
need
yes,
to.
yeah, oh, good, thank you, I appreciate that. There, the 89,
Okay.
straight up arc 10. But I'll show you how to do it with parts.
Okay.
since you didn't ask. I'm gonna show you anyway. Currently integrating arctan by itself. If anyone's interested, there's also a formula for it. Was it actually like 2x or something?
So it was 6 arctan 5y.
6 arctan, thank you. 5y dy. So I'll pull the 6 out front. This is a trick parts. You can do this with the table. What formula was that, Josh?
89.
So formula 89 will knock this out, but I can do it in a cooler way. It's always cooler when you've got the power to knock it out. And I'm going to do parts. So U is going to be this part. I'm going to differentiate that. I'm going to integrate just straight old dy. So I'm going to differentiate here. So this becomes du equals 5 over, and I just happen to know this. Do I?
I think it's 1 plus x squared, or 1.
Yes, that is correct, yes. Yeah, like that, okay, cool. So I differentiate that, dx, and then I integrate up, dy, and then this is just y. And so then uv minus integral v du that's a natural log form. Let u be the denominator. And a little tweaking here and there. So this is just the form du over u. Well, how about we use some, well, this, lots of u's and stuff going around, but that's a natural log form. So just quickly, you need 50. But the formula has a natural log in it, right? Please tell me yes.
Yeah.
Yeah, it does, it does.
Okay, cool. Close enough.
What happened to the 6?
Oh, hey, that's a great question, Fernanda. It disappeared. Let's just forget about it. But what I should do is it should be times the whole final answer. So thank you. Yes. Good question. Busted. Yes, ma'am.
So if you use the formula from that problem, U would be, like, U is in 3 or
Yes. Yep, you have 3y for your problem. Yeah.
So, this is,
Is it like you stuck for a second?
yeah, this is U arctan U, so would it be 3y times arctan 3y?
No, can you bring your paper for a second? Just
I haven't written it.
okay, cool. So yeah, I would like bring the 6 out in front, right? And then I'm gonna let u equal 3y. So then du is 3 dy. So then I have to change this. So that change dy to 1/3 du. So dy is 1/3 du. So I replace that with 1/3 du. This becomes arctan of u, and then I have the 6 out in front. So in the end, it becomes integral 6 arctan u du, and then that 1/3 comes out in front like that. Does that make sense?
Yeah.
I'm not sure.
I just confused on when you're supposed to, like,
Yeah, let's talk.
cause like sometimes you can just plug in with the formula.
Sometimes, so
I just don't know when I can do that.
So, okay, that's a great question. So I can use these formulas directly when it's literally, I just have to replace x for u and it looks the same. But if the formula requires, like if this one here, not just being, okay, good. But like for this set, like, okay, so that's like sine cube of u. So for that one there, 67, if I had integral of sine cube of 20, I couldn't use this formula because it's not just v. So that's when I make the substitution. I go, oh, okay, but what if u was 20v? How could I adjust this formula so that it works? So then I rewrite my problem in terms of u, and a new number will come, like an adjustment factor will come out front, and I use that formula with the adjustment factor. Does that make sense? Okay, awesome.
So only can just go straight to
If it's identical, except for a change of u tax or whatever, yeah, exactly, spin.
Oh, awesome.
Yep. Yep. No, that is partial fractions. Yes. Because the denominator, because it's a rational function, it's a polynomial over a polynomial, and I can factor that bottom nicely as a difference 2 squares. Yeah.
I think I'm just getting stuff like I keep doing wrong. I'm so scared to try problems, but I go to wrong.
No, stop that. No, it's okay. It's just you can always do it again. You're gonna get a lot of math wrong in your career as a mathematician, because that's just part of it. You're too hard on yourself.
I am.
You really are. Don't let it shut you down. Just don't be afraid. It's cool. You got it. You got it.
Oh shit, it's 3:16.
Oh, yeah, it is 3:60. Oh my God. Okay. Hey, it's time. Class is over. Everybody's having such a good time. So, please watch that Friday recording. It's in the content area of World Class. If you haven't, if you have, and you're still like, not, you haven't watched it all, did you watch it all? Listen to my hilarious jokes and shit. Okay, good. Just a few minutes, sir. Thank you.